Welcome to the YouTube channel H2O Chemistry. Subscribe for more videos. You will find chemistry easy here. Today we are going to learn the lesson atomic structure. In this lesson we are going to learn the structure of atom and the various models proposed by scientists. And we learn about the subatomic particles and their properties, isobars, isotones and isotopes, and the geometric representation of an atom and quantum numbers and its significance. So before we go into the topic, we should know some basics. So let us see some basics. So in the previous class, discovery of subatomic particle or fundamental particle we have learned. The subatomic particles are electron, proton and neutron. Apart from this, we have learned cathode ray or anode. Cathode rays or electrons were discovered by J.J. Thomson in 1897 using discharge tube. Similarly, anode rays or protons were discovered by Goldstein using discharge tube. You could see the typical model diagram of discharge tube. And the neutrons by James Chadwick in 1932. 1932, he bombarded the beryllium with alpha particles. We will see about alpha particle in the later session. The new particle emitted have no charge. So it has a no charge, that means neutral. So it is called as neutron. So let us come to the revision of this discharge tube. The discharge tube is a glass tube sealed at both ends. It consists of two metal electrodes. One is cathode, which is connected to the negative end of the battery. Another one is perforated anode, which is connected to the positive end of the battery. The perforated means it has a holes in it. So when any rays comes in, it can pass through it. And at the back side of the anode, some fluorescent materials have been coated. It is made up of zinc sulfide. So when the rays strikes on it, it gives glow. And there is a vacuum pump to reduce the pressure inside. A particular gas is filled inside for the detection of cathode rays. Now we have to maintain at least two conditions to produce cathode rays. The first condition is high voltage for about 10,000 voltage, and second condition is we have to maintain a very low pressure for about 0.01 atm pressure. So at this two conditions, the current will flow. That means from cathode an invisible rays coming towards anode and passes through it and falls on the zinc sulfide screen and produces greenish glow. So these rays are coming from cathode. That's the reason it is called cathode rays. Later it is named as electrons. So who discovered electrons? J.J. Thomson. So with that, the J.J. Thomson have created and model of an atom. So he particularly know about electrons, but he doesn't have any idea about nucleus or protons. So he said in an atom the electrons are embedded in the fixed positions, particular positions like this, and the positive is spread all around the atom. He called it as positive sphere. And this model is very similar to watermelon, because if you see the cross section of watermelon, the red area is like a positive sphere, the seeds are like electrons. So it's otherwise called watermelon or plum budding model, otherwise called Goa model as well. So to check this model, the scientists have tried so many methods. Whatever Thomson said, whether it is correct or not, to check that, the next scientist Lord Rutherford comes in 1911. This new Zealand scientist performed his famous experiment called gold foil experiment or alpha particle scattering experiment. What is famous idea? This is the science concepts used behind it. Opposite charges attracts, plus and minus attracts, same charges repels, plus plus repels, minus minus repels. So, as Thomson said, if the positive charge spreads all around the atom, if you pass one more positive charge like this, they should repel. So that they want to check it. So let us see the gold foil experiment, that's otherwise called Rutherford scattering experiment. Before we learn the experiment, let us see the materials or apparatus used in this experiment. First one, alpha particle, which we said earlier. Alpha particle is nothing but positively charged helium nuclei. Positive charge means it carry plus charge. Helium, the atomic number is 2. It means in the periodic table it occupies the position number 2. That means it consists of 2 protons and 2 electrons. The mass number of helium is 4, so it has a 2 neutrons as well. So in the nucleus, it consists of 2 protons, 2 neutrons and the 2 electrons in the K shell. So if you see the net charge, 2 electron, 2 minus, 2 proton, 2 plus, the net charge is 0. So it is a neutral helium atom. So when you remove this 2 electron from the K shell, there is no electron in the L shell, remember. Now, the nucleus consists of only 2 protons. So, 2 protons, 2 plus, no electrons, 0 minus. So, the net charge is 2 plus. So, it is called helium ion, helium 2 plus. So, now this is called alpha particle. This is called alpha particle because it carry positive charge. Comparatively, we can say it is an alpha particle because the charge and the mass of alpha particle exactly equal to the helium ion, otherwise positively charged helium nuclei. That is the reason. So you know about alpha particle now. The mass and charge is equal to the positively charged helium nuclei. So next part comes. So we have the positive particle now. What is the source of this alpha particle? The source of this alpha particle is nothing but any radioactive metal. So in this case we have taken radium. Radium is a radioactive element which undergoes self-destruction. Remember, self-destruction producing alpha particles. The next question comes, why it is kept in the block of lead? The lead is having a peculiar property, that is, it has a high density. It absorbs all the other radiations, alpha, beta, gamma, other radiations. This opening is very helpful to allow the alpha particle in only particular direction, in the particular direction. So lead is a very high density metal, so which absorbs all other radiations. See, the alpha, beta, gamma radiations are highly dangerous to human beings, so we have to block that. That's the reason only one opening is there to allow the alpha particles in particular direction. So this slit is very helpful to make fine beam of alpha particles. Make the fine beam of alpha particles. Next, we the Rutherford has taken a thin gold foil. A thin gold foil. The main reason is gold is highly malleable metal. That means malleable means we can draw into sheets, that's called the property. Highly malleable metal is very simple. So he has made a thickness for about 100 nanometers. 100 nanometers. The thickness consists of atoms around 400. Atoms around 400. So that kind of very small thickness he has taken. And then look at this circular fluorescent material. Circular fluorescent material which is made up of zinc sulfide. So it is like a in the cathode ray tube it is there in the behind the anode, whereas here it is it's called circular fluorescent screen, which is made up of zinc sulfate. When there is any rays falls on it, it gives glow to that. That is the main purpose. That is the main purpose. Now the Rutherford has bombarded this alpha particle which carry positive charged particles, bombarded the gold foil, a thin gold foil, and he found out whether any rays are coming out or not. To his surprise, he has noted that most of the alpha particles which come from the source have passed through the gold atom and mostly concentrated at the back of the gold foil at this year. So most of the alpha particle pass through the gold foil. A few particles get slightly deflected. You can see this, right? Slightly deflected. Very rarely, for about 180 degree, some rays alone, very rarely, some rays alone will be deflected at the angle of 180 degree. So, by doing calculations, Rutherford confirmed that most of the alpha particles pass through this foil. Most of the alpha particle pass through this foil. I can say, look at this. If it is an atom, most of the alpha particles are passing without any deviation. It means, as Thomson said, the positive charge is not spread all around the atom. That means if it is spread, if the positive charge spreads all around the atom, definitely the alpha particle might have repelled. All the alpha particle might have repelled. But he said most of the alpha particle passed through the gold foil. Some of the alpha particle deflected slightly, because you can see here that particle may hit at the side of the nucleus, so it is split like this, a small deviation, least deflected. A very few alpha particles completely bounced back. That means for about 180 degree. Remember, this 180 degree reflection, it is deflected. It happens 1 in 20,000 alpha particles is deflected like this. That means very rarely it happens. So this is the overall view about Rutherford scattering experiment and its results. So learn this, my dear students. It's very important for your higher studies too. Thank you so much for watching. Subscribe. You will find chemistry very easy here. Thank you.